What's up, everyone? Welcome to a chemical reactions unit here for CPS. Today we are going to very slowly ease ourselves into talking about chemical reactions. We're going to look at something called the law of conservation of mass and how it pertains and how it was discovered. And we'll get more deep into the reactions over the next couple of lectures. But just so I don't spend all that long here on this first slide, let's move over to the next slide and see what we got going for us. So, to start off, a chemical reaction is a change in which one or more substances are converted into new substances. Chemical reactions show chemical changes. The substances that react are called reactants. The substances that are produced are called products. Seems easy enough. And we can see this reaction in the way it is written, and it is almost always written the same way, and that is reactions with an arrow to products. The arrow points at the products. And we can read the arrow as produce or yield. So the reactants produce the products, or the reactants yield the products. Just a little bit of easy nomenclature to kind of get out of the way so we're all talking about the same thing as I use words. Well, a lot of this stuff all has to do with a scientist by the name of Antoine Lavoisier. And he is the guy who first discovered this idea of the law of conservation of mass. And so one of his many experiences that he looked at was looking at candles. And he saw that the mass of a candle and the oxygen inside the container it was burning in was equal to the mass of the remaining candle and whatever gases were produced by the burning. Now, this wasn't the first experience he did. This is easier for us to kind of think about because we've all seen a burning candle and everything. All right. The big question that motivated Lavoisier was what happens when substances changed form, when either they went from one state of matter to another, or even more important, what happened when they totally underwent a radical transformation. And we're going to see a little bit more of that on the next slide. So his main experiments dealt with mercury. And the reason I use the candle example is because we are really familiar with candles. We know what happens to a candle as it burns. We've seen candles on birthday cakes or like around Christmas time at like somebody's house to make the air smell pretty or nice or whatever. And we just don't have the same experience with mercury because it's highly toxic to the human body. But what Lavoisier did is he took a chemical called mercury 2 oxide, all right, known at the time as mercury calx. It was a reddish powder. And he would put it into a sealed container, and you can kind of see that right here. And he would heat that sealed container. And as he heated it, a huge change happened. That red powder started to turn into the silvery liquid that we knew, or he knew, as pure mercury metal, that awesome looking mercury metal that is just so horrible for us. And he also saw that a gas was produced. And to collect that gas, he had the tube of his container go into water and come up into an inverted jar, also filled with water. And as the gas bubbled through, it would push the water out of the jar and he could collect the gas. So this was a huge transformation. It went from a red powder to shiny, silvery liquid and a colorless gas. When he determined the mass of the liquid mercury and the gas together, their combined mass was the same as the mass of the red powder he started with. All right, exactly the same. All right, and so what Lavoisier established is that the gas produced by mercury 2 oxide was a component of just regular air, and he actually called this, I believe he called this dephlogisticated air, but we're not going to get into that. There's a rabbit hole on the discovery of oxygen, and this was one of the steps on the way to really understanding oxygen. If I take a look at it in terms of a chemical reaction, we got mercury oxide, mercury 2 oxide right here. All right, that little S means it's a solid. Mercury 2 oxide, when heated, yields or produces oxygen gas, the little G is a gas, and liquid mercury, the little L is mercury. If he started with 10 grams of his red mercury 2 oxide powder, he got 0.7 grams of gas and 9.3 grams of liquid mercury. And through this, if you look, 9.3 plus 0.7 is 10. So the overall mass in this reaction was conserved, which is how we come up with the name law of conservation of mass. All right, whatever mass reacts is the mass total of all the products. The sum of all the reactants equals the sum of all the products. The mass doesn't change. And we've already seen a little bit of this, but we're going to talk a little bit more about writing equations, some of the fancy symbols that get used. All right, as scientists, I've done none of this. I've just learned it after you. So what scientists did back when they were first realizing all this stuff is they agreed upon a standard form of writing. And they started writing things called chemical equations, which we saw a couple examples of on the last page. All right? And all a chemical equation is, it is a way to describe a chemical reaction. And it uses formulas and other symbols. Some of the more important symbols are over here on this diagram. All right, we already talked about the arrow, meaning produced or yields. It always points at the product. I'm not going to go into detail about a plus sign because you probably know what that is. Little s's, l's, or g's mean the state of matter, solid, liquid, or gas. And once in a while you'll see an AQ, which I know for my school is a bad combination of letters, but it stands for aqueous solution. It means that something is dissolved in water. And then every now and then we might put heat, light, or electricity over the arrow to say that the reactants are exposed to heat, light, or electricity. But you don't usually or always see that. All right, and that's all we're going to do on this today. Just a little bit. Talked about how the mass have to equal each other. And the reason I'm stopping here and it seems kind of quick is because the next part takes a little while and we need to see quite a few examples for it before you'll probably really start to get it. So we'll move into that in lecture 2. And right now, we just kind of started. You have an idea of what a chemical equation is. You've seen one. You've seen about the law of conservation of mass. And that is it. That is all we are going to worry about right now. If this lecture made you think of any questions, feel free to contact me if I am your teacher. You should know how to do that. If I am not your teacher and you found this video out there on the worldwide Google YouTube webs or whatever, feel free to contact your own teacher. If you don't have a teacher, because you like watching videos like this for fun, first thing, congrats, that's awesome. Second thing, maybe try typing the question in the Google. That might help you out as well, but it might confuse you a little more. You could always wait until you see a science teacher again, or just reach out to a science teacher. They will love you asking great science questions. And that is it. Have a good one.